This video is to show you how to do the Pythagorean theorem. But before we talk about that, I first want to talk about square roots. The square root symbol looks like this. So if I did the square root of 36, so what the square root means is you're looking for some number times itself that gives you the number on the inside. It has to be the same number times itself. So the square root of 36 is 6 because 6 times 6 is 36. If I did the square root of 9, my answer would be 3, because 3 times 3 is 9. If I did the square root of 100, I'm looking for some number times itself, which is 100, which would be 10. If I did the square root of 64, that would be 8. Now, these are all nice examples because they're all perfect squares, but obviously there's a lot of times where you do not get exactly a whole number. For example, if I did the square root of 2, that's going to be a number somewhere between 1 and 2, because 1 times 1 is 1 and 2 times 2 is 4. And if you did it, it would actually be kind of like pi, where it's a decimal that goes on forever and ever. So this would be about, if I round to the nearest hundredth, about 1.41 times 1.41 will give you kind of close to 2. If I do another example, like the square root of 14, that's 3 times 3 is 9, and 4 times 4 is 16, so it's somewhere between 3 and 4, a little bit closer to the 4. So if I actually do this, it would be around 3.74 times itself will give you the 14 on the inside. My last one I'm going to show you is if I did the square root of 200. Well, it's not going to, there's no perfect square that's 200, so you're going to have to do some rounding again, and it's going to end up being about 14.14, because 14 times 14 is 196, so it has to be a little bit more than that. So we're going to use this idea of square roots to help us do the Pythagorean theorem. Now, a theorem is a famous rule that works all the time. In this case, the Pythagorean theorem only works for right triangles. So if I made a right triangle over here, the pieces of a right triangle, the two sides that make up the right angle are both called legs. Okay, the shorter side is typically leg A. The longer of the two legs is usually leg B. Now the side that is opposite the right angle is side C, and it's always called the hypotenuse. So Pythagoras, who was a famous mathematician in BC times, actually found that a squared plus b squared always equals c squared. In other words, if you square the value of the leg and then square the value of the other leg and add them together, it always equals the hypotenuse squared. So we're going to use that formula to solve this question right here. So I don't know my c value at all, which is my hypotenuse, but I do know my two legs. So I'm going to go 5 squared plus 12 squared equals c squared. Well, 5 squared is 25, and 12 squared is 144 equals c squared. So if I add these together, 144 plus 25 is 169. So I have one more step in backtracking. The opposite of squaring is to square root. That's why I wanted to show you that first. So if I took the square root of 169, I'm looking for some number times itself that is 169. And if you go ahead and do the square root of 169, you get exactly 13. So 13 times 13 is 169. So this missing side, which is my hypotenuse, would be 13. Okay, here's a second example of the Pythagorean theorem. Again, here's my right angle, and I know this side is 8 and this is 15, so I know my two legs, but I do not know my hypotenuse. So I'm going to go 8 squared plus 15 squared equals c squared. Well, 8 squared is 64, and 15 squared is 225. If I add those together, 225 plus 64 I would be at 289. So I have one last step. I need to square root this. And the square root of 289 is 17. So this missing side, my hypotenuse, is 17. Now my last example for the Pythagorean theorem is sometimes, here's the right angle, sometimes you don't know one of the two legs and you know the hypotenuse instead. You would still set up the same way you usually do. So again, I would go 16 squared, which is one of my legs, plus the other leg, b squared, equals my hypotenuse, which is 34 squared. So then I'm going to do the math to find and solve for b by backtracking. So 16 squared is 256 plus b squared equals 34 squared. 34 times 34 is 1,156. So then if I backtrack to get the b by itself, I'm going to get rid of the 256 by subtracting it on both sides. So I have b squared equals 900. The opposite of squaring is to square root. So then b equals 30. So this missing side, which is a leg, is 30. Now the hypotenuse is always the longest side, so these always are going to be shorter than that. That's another way to check your work as well.